All right. Hello and welcome. Hello and welcome to Kong Builders, the weekly, bi-weekly, once in a while show where we're breaking things on purpose. And this is one of the things we're going to be doing today. This is the place where we hang out, learning technology. We showing. I also learning some stuff, and also sometimes I'm bringing some awesome guests to learn about some cool things, as I am doing today. And today I'm extremely excited to bring Andrew Kew, my friend from Great Britain or from England. I don't know how you prefer. Is it the Great Britain or England?
Yeah, either or. Yeah, Great Britain works as well. Glad to be here.
Yeah.
Thanks, Victor.
First time I met Andrew, it was in London, in person. We were chatting in Hangout, and he's also very known contributor to things what we do here at Kong. You've probably seen him on one of the episodes of the Kongcast, and you probably saw him speaking at Kong Summit. So, but before we jump right in, and we're talking about this just while we're chatting, also let us know how everything is looking, where we're coming from. So I saw some of our regular folks are coming here. So let's see how our comments section is working. Tony TV comes from Manitoba. Manitoba, is it somewhere where in Canada? Hopefully it's not too cold. Okay, so our comments work. Also, write down if you come in. We should go with stream in multiple places. We should go in LinkedIn. We should go with YouTube, Twitch, in multiple places. So write down where we're coming to. So right now I see at least 7 people, live, and I am collecting some of the metrics in terms of like where the people coming from. Andrew, tell us a little bit about yourself. Like what brought you here? And I already introduced you with some of the things that you contributed to at Kong and the community. And yeah, so what do you do? What are you up to these days? I saw you have a bunch of the gorillas on your bookshelf, and you have the plush Docker.
Yes. Thanks, Victor. Effectively, my day job, I founded and run a software consultancy here in the United Kingdom. We specialize in microservices and integration. And effectively, Kong is one of our tech partners. So we've partnered with Kong, and I have been set in a residency program within Kong to basically help out in the customer experience team. So I'm effectively a technical account manager or field engineer in the Kong CX team. Going out into clients and helping them deploy Kong, helping them improve their architectures, reviewing their designs, but then also helping them with the full ecosystem of where they've deployed it, sort of anywhere in the cloud or even on-prem as well. And that's probably where the Docker whale comes into it as well. So a lot of what I do is Kubernetes based, but it's not solely, it's just in Kubernetes. So I do a lot of kind of VM work as well. And that's probably where I've come from in the last couple of years, working from bare metal through to VM in the cloud and then onto containerization as well.
And a lot of things that we're going to be doing today, you can find Andrew actually in the LinkedIn if you want to hang out with him and ask some of the questions afterwards. But also, you can find me on Twitter, by the way. So we're going to be doing a lot of cool things today. We're going to be talking a lot about containers, right? So I think one of the ideas and one of the themes that we see in recent years when we're talking about microservices, when we're talking about modernizing, I'm not gonna call specifically microservices because it's one of the things that people are doing to modernize their IT infrastructure, the way how they deploy and deliver apps, and the containers actually help to spearhead kind of the evolution or revolution rather of how people deliver software. So we announced this topic for today is chaos engineering, and as many things in IT, many things in the software development world, it has a little bit cryptic sometimes notation. We know that there's the companies like web scale companies like Netflix. They like to break things on purpose, and this is what we're going to be talking today. This is what I want to learn, and hopefully we'll share some ideas. So Andrew did presentation at the Kong Summit this year at San Francisco. He was talking about chaos engineering. So we hang out afterwards. Also, Andrew helped me a lot with the developer keynote, and he also presented some of the cool bits with the Kong gateway operator. You can, again, if you subscribe to this channel, you've probably seen some of the videos that we share on the Kong Summit, so you can go and watch this keynote. But beyond the topic, it's going to be beyond the topic of today. We're going to talk about chaos engineering, and not just talking about. So the Kong Builders is where we doing things, right? So we're gonna see how we can break things on purpose. So let's start just to bringing everyone up to speed and welcome everyone. We see Lior from Tel Aviv. I see some people from Canada. Daniel from Canada. Harsh from London. So we have a pretty cool geography here. It's great. Also, we like to know what you're drinking. So I'm drinking today water. Andrew, what are you drinking today?
Coffee for me this evening.
Nice.
Yeah.
All right, coffee. That's great. It's already evening. I thought you will say tea. Sorry, I had to pun this. It should be like a tea time. It's already around
Yeah,
like what 5 p.m. In London. So
yeah.
yeah,
I don't think I'm
why?
British enough to be having tea.
I'm not British at all, but I love tea. I prefer tea sometimes to coffee. Love the Earl Grey, like the
Yes,
leaved one and things like that.
good, good choice. Good choice.
Yep. So the Sunil is jumping just in front of Gun. It's just okay. So let's get to the point. Like, okay, what kind of tool you gonna introduce? Sunil, brace yourself. It's gonna be a good stream. Um, okay. So what is Negroni? Where is it? Neve, where is it? Where are you coming from? What is that? Is it what's it? Is it a country or a town? Let us know. All right. So Andrew, why breaking things on purpose? Like we don't want to break things, right? We want to have a very solid environment. So why to bring? Why to break?
I think that's kind of the whole premise of it, is resilience and ensuring that your platforms are resilient and they can or the behavior to particular failures. And that's kind of the whole thing with chaos engineering. It's injecting failure in a controlled environment and then observing the behavior of your platform and seeing, how does it behave and is it how you expected? Hopefully it is, but if it isn't, you then have the opportunity to, resolve it, reconfigure, maybe change your architecture if it's something that you can do that way, or if it's something you can't change, then at least you know what the failure will be and how you can resolve it when it happens in production. And I think that's the whole idea behind breaking it on purpose. You're breaking
I
it to
think
basically make it more resilient.
yeah, I think it's the also good thing to point out that when we're talking about certain technology, where we're talking about certain things, um, people like to come and say, "Hey, how I can install this chaos engineering, or how I can install this zero trust security." And it is very interesting thing with the modern software. And the Sunil just like in the chat, he also jumped immediately like, "What kind of tools we can use?" But I think it's very important to point out, and Andrew can agree or disagree with me, that it is more like how you start thinking about your software, how you embracing certain challenges. One of the things what I like to say about the specifically chaos engineering and the way how you're breaking things in purpose in environments where, I mean, like work environments, everything is still human factors involved in environments which enables you to do experiments and will not punish you for the failures. Embracing the world, in ideal world, we live in not ideal world, like most likely things will break because of network, things will break because of connectivity and all these kind of things, and you cannot fight those things. Only thing that you can embrace it and learn how to live this in this world. When I came from distributed database worlds and distributed systems world, we have this like a CAP theorem. um, Even though over the time when my thinking evolved, I realized that this theorem is actually like too, I would like too like a narrow-minded to explain complexities of the system that happen, because everything there would be different trade-offs. However, embracing kind of partial availability system versus like a full in availability system, it's still better. Or you can also switch to partial consistency in case of network in case of network partitioning. So sometimes it is okay to um, have partial performance degradation, maybe slowing down things, right? Or sometimes even giving like a stale response. And some of the things that we will be talking about those things, and those things are available specifically, like the ways how you can make sure that the system will not have a cascading failures, implementing something like circuit breakers that will do like a uh, short circuit to the failure, and it will not propagate things, or things with like rate limiting that implements between the nodes of our systems. So I'm passing the microphone to Andrew so he can talk a little bit about his presentation and what kind of setup we will have here. Don't forget, this is the interactive session. This is the difference between like we do. It's not a webinar; it's a live stream. We're gonna be actually digging into the code and we'll trying to break some things in front of your eyes. So be present, asking question. That's the reason why we're doing this, because we also have interactivity, right?
Yeah, absolutely. And I think just to go to build on what you've said as well, Victor, I think the the one aspect of the discipline, I guess, of chaos engineering is to ensure, that you've you've taken into account things like, if you're in the cloud, for argument's sake, that you're actually designed your systems in the way that things should be running within the cloud, and there are certain patterns that you follow and things you need to take into account, like your services being pulled for whatever reason, whether it's a failure on the server, or whether it's Amazon deciding that they want to, or any of the cloud providers deciding they want to pull any of those services. So ensuring that that's all configured. You've got multi AZ, so your service is running in multiple zones, i.e., multiple data centers, and that's at a high level, if we're just looking at the architecture, that's what it should hopefully help you with as well. Ensuring that you do have that resilience, and then self-healing. That you've maybe configured your platform so it can auto scale, or it can manage the failure effectively. And I think that's ultimately what everyone should be doing, just to ensure that everything is ready in case this happens in production. And that's kind of the premise behind the whole topic, really.
Yeah, and I just brought up the our stream to Twitter. If you come in also from Twitter, let us know what what are you doing and stuff like that. So yeah, that's hopefully we'll have a little bit more people to create this more chaos in this stream as well. So
Yeah, absolutely. So I mean, what we can do is we can have a look at one of the tools that I've been using quickly, before we dive into actually breaking anything.
yeah,
And
exactly.
one of the tools, one of the tools that I've been using. There are a number of them out there, but the one I've been using is called ChaosMesh, and it's a really, really nice tool. I'm running it on Kubernetes, but I think you can get it to run on VM as well, or bare metal. But it's a really nice tool that allows you to define your experiment. So, the failure that you want to inject into your system. So just to kind of briefly have a look at a new experiment, you can see from a Kubernetes standpoint, there's a whole raft of different experiments that you can build out of the box, and you can choose from a combination of these as well. You can schedule them, you can chain them. There's a lot that you can do, and effectively, it helps with, I guess, deciding what it is you want to inject, what failure it is, and then coming here and choosing that and injecting it into the system.
There's some other tools that's available on market, and I think like ChaosMesh is specifically we're gonna be using because of the mesh. But also we had in this channel you can find a playlist with the Concast episodes where I was talking to one of the developer relations engineers from Gremlin, which also another chaos engineering tool that you can and there's also a pretty cool demo. So just something to consider and to watch in in the meantime if you also want to learn something like this.
Yeah, absolutely. And I think one of the probably the first tools out there, which if people have heard of it, is called Chaos Monkey, which effectively was the first tool that Netflix open sourced back in, I think it was 2010. They effectively were the company that coined the term chaos engineering, and it was their migration from on-prem or bare metal servers to more kind of cloud distributed systems, where they then built this tool Chaos Monkey, and I think it's still available. There's still a GitHub page for Chaos Monkey that you can go and download it and use it. I didn't actually
I'm
try it, but I
I'm
found
trying to
this
come up with
Chaos Mesh is good.
some sort of pun for this, like a chaos monkey, and there's a gorilla, and things like that. So
Yeah, absolutely.
so Sunil is
Cool.
throwing some ideas around. So Gremlin, Chaos Tool, Harness, Chaos Monkey, and etc. Yeah. So we're gonna be focusing on some of the things. Plus, think about this. Some of the bits that's available inside Service Mesh, like Kuma, they also can be used as a starter point to apply some of the experiments. But one of the things that um, you want to do, and this is what Andrew will be showing later today, you cannot control something. So you try to gain back control during the chaos, during the failures. And I think if you cannot measure it, so you will not be able to gain control. So that's why integrating with some sort of like observability component also is important bit of the overall discipline, right? And this is again, I am jumping in front of the gun, and Andrew will have something to talk about this.
Yeah, absolutely. So, I've brought up just one of the slides from my talk, talking about the main principles. I guess in a way of building an experiment that you can use to apply this chaos into your system or this error. And, the whole idea behind it is building a hypothesis, deciding what it is you want to test. What error you want to throw in, then choosing the smallest type of experiment, the smallest error you can, and where you're going to inject it into your system. And then finally, like you were saying, around the topic of observability, being able to measure and see the impact, and then hopefully improving your platform. Or like I said, if you're not able to improve it, then at least you understand the behavior. And I think it's that understanding the behavior of your platform that's very important here. Because it's effectively turning an unknown behavior into a known behavior, whether it's something you can fix or whether it's something that you then understand, that you can, move or have the knowledge of for when it does happen, how to resolve it, And I
Right.
think having that knowledge is, especially for your support team, the teams that are probably going to get woken up at 2 o'clock in the morning when there's an outage. As long as they've got playbooks, a playbook on how to resolve this particular issue, then actually it's not the end of the world, or not a massive impact if they can get things back up and running. It's when you don't know what happened, and then you've got to start investigating it, and effectively, like if I go back to the issue that Netflix had originally, I think it was 2008 when they had their major outage. It took them 3 days to work out what the problem was. And they probably didn't have a really good observability layer, to be able to see, was it a disk problem? Was it a RAM problem, or just getting that visibility as to where the problem
I just
lies.
wanted to bring some of the my favorite fallacies of distributed systems, and one of the things that Andrew already mentioned. So network, if you're thinking that your network is reliable, it's not true. Latency is a bitch, so you will be definitely will face this. You have infinite bandwidth, so you will be capped by your cloud provider most likely, or you will be capped by your network team. So network is secure, and the network is most importantly homogeneous, and when we will be running into multiple environments, so like different regions, or maybe things around. Some of the bits are running inside Kubernetes, some of the bits are running inside bare metal, and those systems need to communicate somehow. So
yeah, absolutely. Cool. I mean, I wonder if there's maybe time to, unless there are any questions that anyone has, we can start maybe having a look at, getting our hands dirty a little bit, and
yeah,
just start having a play with one of the clusters, or actually the set of clusters that I've got. So this was effectively the setup that I did for the summit presentation. So I'm running Kuma, and I'm running it in basically what's called global zone mode, or global zone deployment. So I effectively have a global
Control plane.
control plane, yeah, or in its own cluster running up at the top. And then I have its own control plane, and then I have two zone clusters below as well. And each of those zone clusters are then running a service. So the nice thing here is it's across clusters rather than it being like on the same machine or the same cluster. So we've got that that network communication that's kind of going through between the both. So yeah,
Oh,
both of
oh,
those
hi. How much?
clusters.
Like a heterogeneous network. Hello. That's I am.
Yeah, exactly. Right there. Right there. um, then effectively in each of the zones, I've got just an echo service running. So, I'll send a request, it back echoes the request back to us as the response. So just something very simple. Didn't want to go too far down the road with that. And effectively using a mesh gateway to get into the mesh, and using the power of Kuma to effectively load balance between the two services in the two clusters using what's called a zone ingress, and that comes out of the box with Kuma Mesh. A really really nice feature, being able to load balance between clusters, not just load balancing between pods in the same cluster. So really really nice feature that I'll be hinging off of. Then observability, which is one of the things we spoke about as well. I've got Prometheus running in each of the zone clusters, and then I've got a Prometheus in the global cluster up at the top, and using that to effectively push the metrics up. So we've got a single location for metrics, so that we can view things at a global level rather than having to see what was going on and in a zone by zone level. So just using Prometheus feature called remote write, which is effectively just pushing the metrics straight up to a centralized Prometheus instance. And then using Grafana to effectively view the stats. So yeah, that's effectively what I've got running that we can start playing with. There's another tool called K6 as well,
Yes, that's something
which
that
I'll be
I wanted
using
to
to.
to ask. What is that, and how we can use this?
Yes, yeah. So K6 is a really nice load testing tool, and you can use it to effectively generate load. And there are a number of ways you can do it. It works by writing very simple JavaScript files, and it has a whole lot of libraries with it where you can do things like send consistent or constant load. You can do multiple virtual users. You can also do like step functions as well, where you send a certain number of transactions a second and then step that up as you kind of go through time. You can almost build your testing framework very simply, or very in a very complex manner as well. And actually, let's jump in, and I can show you what one of those scripts looks like as well. That might be a good way to give everyone a bit of a flavor as to what it looks like. So if I just move this down, and that's effectively the JavaScript. Very simple as well. I'm doing an import for a particular library. I'm setting some options, and then I'm basically just calling my get on an endpoint. And it's as simple as that. But if you have a look at the scenario that I'm effectively running, I think that's for this use case. That's where we're getting the scenario that we want to run. So I'm doing a constant request rate. I'm doing a rate of one request a second, going for a duration of 10 seconds, and I'm using a maximum of one virtual users. So I didn't want to hammer my cluster too badly. I wasn't trying to test out performance in this case, but it at least gave me something to be able to generate some load on the cluster. If you want to do something like test out auto scaling, for argument's sake, or how many requests or how many concurrent users can hit my service in one time. You can tweak these numbers and get much higher TPS, much higher virtual users as well, and actually start observing the behavior of sort of more of a load testing or performance testing scenario as well.
I get to use this tool called Locust, but it uses Python. So I think the JavaScript is more for me would be more interesting language to use. Not a huge fan of Python, but I would like to remind that there's still a video that needs to collect 100 likes. So I will start doing some of the performance testing live sessions where we're going to be bringing Kong and other components down through using those tools. Speaking about this KDS, so do you running this somewhere on some of the environments so you can point this to any location, or there is a I don't know, maybe there's a managed service that allows to just like upload your scenario and they will be able to handle all this infrastructure growth for you. If I need to do kind
You
of
mean
like
with K6?
Yeah, K6. Like if I want to do distributed performance measurement. So I don't want to do like distributed denial of service type of attack, but sometimes when I run my systems in open internet, I want to have open internet system that also will try to generate some load.
Yeah, absolutely. I don't know of K6 that do that. This is running locally on my machine and just hitting an endpoint. You can have it running in your cluster. So I guess effectively, you could have a container or a pod running. You could have multiple pods running and getting all of them to maybe pull things. So you could probably create yourself a distributed load testing system within, EKS or something like that. K6 themselves have actually been brought into the Grafana labs. So I'm sure there'll be more, we'll see more from them in the future. And you never know, there may end up being something, Grafana has their cloud offering, their SaaS offering. They may end up bringing something in with K6 and giving you some kind of SaaS offering for performance testing. You never know.
That's why we're here. We're giving the startups ideas in the show. So like watching us, you're not only learning something new, but also you might get the startup idea. So Sunil is asking about delay in response. Sunil, can you be like more specific in this question? Is it with regards of configuring the KDS or how to measure it? That would be great to have a little bit more details on this question.
Yeah. So just quickly looking at a bit of observability as well. So I've got Grafana, which is what I was talking about as well. And if we just quickly have a look at a couple of aspects of it, I've got, let's do it for the last 6 hours. So, and just zoom in there a little bit. So K6 has a really nice dashboard as well. So, you can have a look at your performance tests. And as they're running, you can get sort of live information as to what's going on and what tests that, the data around those tests as well, which is really nice if you're getting any errors. So, again, centralizing, it's that central observability of not only your platform, but also your load testing as well. And then being able to, I guess, marry all of this up with, because, you can build whatever dashboards you want in Grafana. So take one of these panels, create a dashboard that's got your load testing as well as your systems, and then you can kind of start investigating at which point things were happening. So a really nice addition. I think this is, it's on the Grafana, what do you call it? Dashboard portal where we can download and import them. Yeah. So it's all public. You'll be able to pull that and get it as well.
That's pretty cool. So instead of collecting the data in some sort of like text format, always see this in a visual format.
Yeah, exactly right. And then for our testing as well, I've created my own dashboard You can see Kong Summit. So I did this for Summit, and this will effectively be, when we start breaking things. If I just open that guy there, this is where we'll start having a look at certain aspects to, I guess, what I want to do to show today. And it gives us again visibility as to what things look like. You can see I've got some failures here, and we can kind of talk through that and maybe even run it live as well, so you can see it, and see what it looks like, and
So you also will be able to
give you a view of it.
collect those metrics out of Kuma, and collect the metrics out of Gateway and the responses. So in this particular case, we have a 200s, we have a 400s, not so many 400s, but I see a few of 500s, meaning that's a paid gateway, bad. So
yeah, exactly. So these panels here are actually coming from the out of the box observability you get with Kuma Mesh, which is great. And then some of them were coming from K6 as well. So I kind of mixed and matched, like I was saying, between some of the K6 ones, some of the Kuma ones, and then from that it gave me a good idea as to what was going on and what the problem was. The other thing I actually wanted to talk about quickly, so just having a look at ChaosMesh, and the one thing I really like about it is ChaosMesh can actually, your experiments can be defined in YAML, which is really, really nice. So you can take those experiments and you can apply them, so in a GitOps fashion, and then you can rerun these via your CI/CD pipelines. So rather than having tools where you've maybe got to run a CLI tool, or you've got to have something else added, once you've got this installed into your cluster, effectively just applying this YAML, and we'll do that as well. You'll see it running the experiment, and in this case, this is a PodChaos. So what this will effectively be doing is the action of a pod failure. So it pulls a pod down, and it runs for a duration of 3 minutes. So my pod comes down for 3 minutes. And effectively, that's what we'll look at injecting into the cluster.
Just a quick question on this one. So this ChaosMesh, it's gonna be controller that installed inside the Kubernetes cluster that will be handling some of those like a Kubernetes specific issues, right? And when we have this policy will be applied, and this controller will be ultimately controlling how those pods will go up and down, things like that, right?
Yeah, that's exactly right. And I can probably show you that as well. If I jump into K9 as well, anyone out there who is not using K9, I highly recommend it as a tool for viewing your clusters. So not a complete replacement for a kubectl, but it definitely speeds up my day-to-day using of clusters. So
the attendees of this live stream, they already are very accustomed to K9s, because most of the demos I used it there, and
you use
people,
it as well. Yeah.
navigating through the things.
Yeah, definitely. I think I got the tip from you, seeing you use it at one of our talks that we did, and then haven't looked back since. So great tip, thanks. So yeah, just having a look here. These are the pods that are deployed when you deploy Chaos Mesh, and effectively you've got a dashboard. You've got some daemons as well that are effectively running on each of your nodes, so they're running as daemon sets. And then you've just got for redundancy, some controller managers as well. Those are the ones that are effectively listening out for any injection of experiments, and then effectively the daemons will go out and do whatever it is you need to. If there's anything at the point of needing to do something at a server level, you actually have to install something on the physical node. So if it's Kubernetes, your worker node, you'll need to build a custom AMI for that worker node with that additional library added, so that it can do anything if it's any kind of experiment or failure almost below the cluster level. So there is that one consideration that you would need to take into account as well.
Very nice. So we have a K6 to generate load. We have ChaosMesh to generate some of the failures. We do have a Prometheus to capture all the metrics will be captured in Prometheus, and Grafana for visualization.
Yeah, that's right. That's right. So having a look at just a simple test as well, so in this case, following those principles that I was talking about before, defining a hypothesis, so basically a failure of a service within a zone mesh should have no impact to a consumer, so no errors. So from a consumer standpoint, they don't really want to know about any failures within your mesh. The experiment which I was showing you, that YAML within ChaosMesh is injecting pod failure into the zone. And then effectively we'll observe it and then work out what it is we can do to improve it, rerun the experiment, and then hopefully get a better output at the end of that. That's effectively what we will do. So just showing you here, this is what we were speaking about, using K6 to generate load to those Echo services, and then using ChaosMesh to effectively pull down one of the pods, and then basically view what's happened.
Okay, let's see how it goes.
Let's do that. Yeah. So I need to be on the zone 1.
And the zone 1 is this case, it's a EKS cluster in somewhere.
Yeah, that's right. So if I go back to here, this cluster on the left is my zone 1 cluster. And then on the right is the zone 2 cluster. And then the global one was the one up at the top. So we'll be basically calling everything into this one zone, and it will be load balancing between the two zones. So what I actually have here is I've got a no retries. So if I just show you this, because I think I might have to change the name as well. So this is effectively a ChaosMesh YAML file that has the experiment that we're going to run. And I'm going to call it Kong Builders. It's running a pod failure for 3 minutes. That's effectively what that's doing. So what I'm going to do is I'm going to apply this. That'll apply it. And then if I switch across to my experiments, you can now see there's my experiment running, and that's the Kong Builders one that we just did. So that's going to effectively run for 3 minutes and pull down that particular one pod. So what I'm going to do is I'm going to go and run that K6 experiment, and that will effectively be, hold on a sec, I need to do a port forward. I'll explain that in a second, and then I'll rerun that again. Cool. So effectively, to get K6 to have your data within Grafana, you need to push it into an InfluxDB instance, which I've just got running in that zone 1 instance as well. So I'm just going to come in here, and if we go to load testing, last 5 minutes, and as you can see, we're starting to get some data coming through as well, so we can see that our experiment is effectively running, or our load testing is effectively running. If I come in here,
how we can see, yeah, exactly.
Yeah, so this is effectively the, I need to refresh that. Let me do the last 5 minutes, that's probably better. And then refresh. And then this should effectively start showing us some errors coming through. It's probably not going to be as a nice diagram as the one I previously showed you, just because I needed to start things at the beginning. So you can actually see here, there's some errors coming through there. And it might even be, by the time I took to show you everything that this guy's almost finished as well. Um,
So
so
so so right now, this is the data that we captured from where? So from the K6, the load generated, because initially you said that our consumers of API should not feel if one of the nodes went down. So how you let's explain this, the numbers a little bit. So we still have some 500 type of errors.
yeah, exactly. I think that's kind of the point of what I'm trying to show here. So like I'm running a test where we are getting some errors, and effectively the the consumer is seeing the errors because there's an issue with the cluster, and that's kind of the premise of what I guess and what I'm showing here is what we will do is then reconfigure Kuma with a policy. It has something called a retry policy, and you can effectively apply that
Again,
policy. And
sorry for jumping in front of the gun. Yes, it makes sense. Yeah.
jump in the gun, yeah, that's okay, that's okay. Um, So what I'm actually going to do here, I think that guy's still running. I'm going to re-inject this again
Mm-hmm.
so we can get some more errors.
Yeah, while you're doing this, I
Um,
will explain one more time what happens here. So, the idea of this experiment is that we're gonna be breaking this system and see what kind of behavior we're gonna be observing. Because in future we want to improve this behavior. Because right now, if consumer hits the pod that is restarting or pod is unavailable for 30 minutes, gateway will, because gateway fronted this service, gateway will throw 500 error. We want to avoid this, and this is going to be our next step. How are we going to be using the data that we collected through this experiment in order to improve our system reliability?
yeah, exactly. And you can see here the failures are starting to come through. Effectively, and this was me talking about observing the behavior and then seeing whether you can improve what you've got. And in this case, a very simple example. In this case, the improving is going to be applying a policy to my mesh that effectively handles the failure better. In this case, it's something that's internal to Kuma, to Kuma Mesh, but it could be anything else. It could be any. This was just the scenario or the hypothesis that I chose. Yeah, and here you can start seeing those 500 errors are increasing. I'm starting to get failures coming through, and these failures, now that they're greater than zero, effectively means the consumer is getting errors, because every now and again it'll be trying to load balance to a pod that doesn't exist or a pod that's been pulled down, and effectively returning that 500 error back to the consumer. And that's what you don't want,
Exactly.
because
Exactly.
you don't, yeah, at the end of the day, the fact that you are load balancing between two clusters, and there's an issue between your clusters, whether it's the service gone down or the comms between your two zone clusters, that's I guess implementation detail, that you as a platform support or company should be managing yourselves,
And
and
another
and,
thing
and
is that
resolving.
since Andrew mentioned about a little bit about implementation details, usually if we're talking about this as this experiment needs to be, but by the way, this experiment needs to be constant. This needs to be part of some sort of integration testing phase of your application when you're rolling things out, because this is still place where you can affect certain things. Yeah, it's good that you will be able to. I test my code in production, but also there's a chance to do some improvements here. And one of the things that people usually can do, if they're not using any like software-defined network systems like ChaosMesh, they would have to go and implement those kind of like logic in terms of how to do proper pushback, or maybe implement a built-in like circuit breakers. Some of the tools, some of the frameworks, some of the languages, they already include the implementation of those tools. But with service mesh, that is what we will. I hope that's the expectation that we're gonna be seeing. Those things can be implemented on the fly. And again, things that Andrew mentioned, with the when we have a declarative definition of those things, we have ability to implement those as a part of some sort of like a pipeline, some sort of CI/CD pipeline, where continuous integration pipeline that will be you have a run this hypothesis, and you collect the data in your integration testing phase or your development phase, and after that, for your infrastructure, when you're rolling this out, you will be implementing those policies that would allow to mitigate this type of failures.
Yeah, absolutely. And the way I see it is, I see it as unit testing for your platform.
Yeah.
As part of your CI/CD pipelines, you run your integration tests, you run your unit tests for all of your code for your microservices. But who's actually running those kinds of unit tests for your platform to ensure that maybe if someone changes, especially if things are built with infrastructure as code, is adding a new component to it breaking something, or have we actually configured it correctly within the declarative configs of your infrastructure as well. And that's how I see it being used, and actually running it on a daily basis, or even on a change by change basis if you're able to. Depends on how large it is, the platform that you need to stand up takes. It could be an overnight sort of test that runs and sort of runs your whole suite of tests, and then you get the results in the morning.
Exactly.
Cool. So just jumping into what I want to show next. So we just spoke about an issue that we've just shown with those errors, and one of the benefits with Kuma, like I said, is that it has these built-in policies for you to manage failure. And one of the most simplest one is a retry policy. And that's kind of the one that I'm going to show here. So just applying that retry policy, effectively what it will do is, if there is a service that's out, so in other words, the pod that's not there, it will try a couple of times, and then it will revert the traffic to the service that does exist. So effectively within the mesh, you are then handling that error. So like we were saying, the consumer then shouldn't be able to see any issues, and that's effectively what we will be doing now. And then I'll run that and just kind of show you what the results look like as well.
And most likely, what we will see is increased latency, and this is also piggybacks to my initial point where I was talking about the different trade-offs that you need to understand in distributed systems world. Sometimes increasing latency is better than getting errors. Spending 1 second on the spinning loading ball, maybe it's better than getting the confusing bad gateway response to consumer of your API. And this is something that the teams need to decide what is better for them, what gonna be user experience they're getting. Sometimes, if it's a consumer of this API, is a mobile app, they will be able to kind of figure out and show the nice message that the new data is not available. We're showing the only local data, whatever is maybe a little bit stale. Sometimes they don't need to even talk about this. They will just set a latest greatest data or latest greatest update response will be blah. So again, it's to the point where you need to agree with your across the engineering, across the product leaders, what is the user experience you're trying to get to your users, and what would be suitable and appropriate response and user experience. Sometimes you even can put if you're doing this API as a product, those latencies you can even include in your SLA, saying sometimes the 90 percentile you will get X response per minute, meaning that you still have a headroom for certain errors, like when the latency increases. So those things need to be agreed between people. That's the people part. Technology-wise, you got you covered, but the experience-wise and how those numbers would be interpreted, it needs to be handled across the teams.
Yeah, absolutely. So effectively, what I've done is I've applied a retry policy, and I'm just going to jump onto cluster and just see, and I've effectively got a retry policy now running. This is on my zone 1 cluster. So, with a multi-zone configuration with Kuma, you apply it at the global control plane, and that then pushes it down to both of the zone clusters as well. So you only have to apply it at one sort of centralized location, the global control plane, and that gets pushed down to all of your zones, which is a really really
Can
nice
we take a
feature
look at
again.
can we take a look on the policy real quick? While I was talking, you're probably showing the things. You can do either edit. Yep,
Yeah,
perfect.
yeah. There we go. So if I do full screen,
Yep.
so that's effectively it. It's a particular CRD that's a Kuma built one for retries, and I've basically just told it to. There's a lot of default settings here, but I've effectively just told it to retry 5 times on HTTP, and that's effectively what it's going to do, because it's not actually using any of the other protocols. So effectively, it's going to try 5 times. If that doesn't work, it will then revert the traffic to a service that's actually working, and that's
And
effectively what that retry
interesting
policy will
thing
do.
here that one of the things that I was also was talking about, the cascading failures. Retries are good unless those retries are also controlled. As you can see here, in there is a back off policy as well available, so you don't want to just do boom boom
Yeah.
boom. If the retry failed, it will try to wait a certain moment of time, and after that try it one more time. So it's better to have this kind of uh, I'm a bad at math. Maybe it's an exponential one, right? So we're gonna be doing the retry with the some grace period.
Yeah, exponential back off. Yeah,
Yeah.
absolutely, absolutely.
Um.
Cool. Now that that's applied, I'm just going to rerun my test again, um, and then no, I probably need to do that,
Mm-hmm.
and then let's have a look here. So with retry. So again, this is going to be our with retry policy. Let's change the name to Kong Builders. Okay. And then let's go here and have a look. See the last 5 minutes. Refreshing. Okay. Let's get some data coming through. And then I'll apply that failure again. And this time, and that's what's quite hopefully quite evident as well. We should get no failures. It's being resolved by Kuma. But what we will see is the retry count, and that you will see it trying to retry a particular service. So where before, which I can zoom into after this, there were no retries because that policy didn't exist. So,
Mm-hmm.
you can get some stats on what it is doing internally in the cluster as well, which is really nice. So yeah, let that go for a second, and then what I'm going to do is then apply this guy. And if we jump back to here, you should see, yeah, there's my with retry policy, Kong Builders. So that's again, same experiment, pod failure, running for 3 minutes. And then, yeah, jumping into here, we should hopefully start seeing no failures and some retry counts coming through. And then that'll effectively show you, that the retry policy of the mesh is working. And again, round to the whole topic of chaos engineering, what we've done is we've effectively
Oh, here we go.
observed the behavior. Here we go. There's some retries coming through. Observed the
Yep.
behavior. We've gone, this is what's happened. That's not what I want. And I've improved what I've got, and then rerun it again. And now we can see, while these retries are coming in, you can see that there are only 200s coming through. There's no 500s. There's no errors, no failures coming through, and effectively, improved, I guess, the response of our platform, just by testing to ensure, in this case, that we've configured our mesh in the right way.
Okay. I think it's great. I think it's awesome, and I think this is actually, that covers many aspects of today's conversation. And I would like to say that, Andrew, if you have any like pointers where the people can pick up your demo, if it's like available somewhere on GitHub, if they want to play around, or how to learn more from this from the session, maybe you have published slides somewhere so that people can like take a look on those things.
Yeah, I think if you want to do that, reach out to me on LinkedIn. I haven't yet published the this demo on GitHub, but that'll be something I'll be doing in the next couple of weeks. So I'll be
Yep.
posting that on GitHub. But yeah, reach out to me on LinkedIn. I'm more than happy to show you this, point you in the right direction, and just get you started ready in this domain.
Yeah, absolutely. So, and always don't forget to subscribe to our YouTube channel. And this is the Kong Inc., where you can find every material, every possible things with regards to your cloud connectivity APIs, API connectivity, Kubernetes, and all these kind of things. And again, thank you for those of you who were with us in this session live and asking the question. And those of you who are watching this offline, you can always write down the comments and ask any appropriate questions. Subscribe to this one. Join the Quant Nation in our forum, asking question there. We also working on enabling Slack, so you can go and come and chat with us. So stay tuned for those announcements. And yeah, so for today. Again, I'm super excited to bring you some of the guests. Give us some of the reactions if you like the show, and hopefully Andrew got his the payment increased, and he will get the some karma points for being awesome Kong champion. Again, Kong champion program is the our community program inside the Kong, where we're recognizing some individuals who help others to learn about Kong, about cloud connectivity, about APIs, like people like Andrew, like speaking at the meetups and sharing some of the knowledge and coming up with some cool ideas. It's a great community for individuals. If you want to join us, um, please reach out and show some of your cool stuff around the Kong, and we will nominate you for the next round. So, Andrew, thank you so much for being part of Kong Builders. With this, I would like to say my name is Victor Gamov, and as always, have a nice day.